Hi, welcome to your lab session. So now some of you have raised the concern that how to work with visitors uh, generated by Antlr in your IntelliJ IDE. So today's session is to go in detail about visitor and also learn or draw a connection between regular expression and the grammar that we are working with Antlr on the IDE. So for this reason, I've created a very simple example. This grammar, it's to parse comma separated value file or CSV file. Now in the lab, you already have code for CSV parser, but I have slightly modified the code to make it do a few more things. In case you want to download the code, I have made this available on GitHub, which you can download from here. Now, if you need to pause your video and copy the address URL to be able to download the code for this particular example, then please go ahead and do it. Another thing I have noticed in the lab that a lot of you, you download the project or the code and try to make it work on your IDE. Now, the biggest issue with that is that the project code that we have provided often doesn't have the same path as your local computer. That's why you will see when you try to run the same code directly from the project by putting the code in the IDE, you might get errors. Another issue that can happen is technically because of a missing library that your project might be dependent on. So the best thing to do in this case, after you have downloaded the code, reuse parts of the code into a new project. Now, by now, you should already know how to create new project. So you should be doing on your IDE, go to File in the menu, do a new, and create a new project from there. Call this project as CSV. After you have created the new project, now I don't have to do it because I already have the project created on my local computer, but go ahead and create the project on your computer. After you have done that, track down the SRC or source folder for your project. Once you have found the SRC folder for your project in your new project that you have just created, right click on it and find the option new, then create a new file. This file will be actually your CSV, like the grammar for CSV parser. Call it csv.g4 and then press enter. Now, when you do it, you will see that you have a blank grammar file created with the name csv.g4. Now, you can copy paste the code from the repository that you have downloaded from GitHub, or you can pause the video here and you can copy the code from the screen. Now, before we go ahead with what this program or project is supposed to do, I want to quickly show you the output and the input that we are using. So if you already have a csv.g4 created and copy pasted the code for the grammar file, track your SRC or source folder and create another new file, which will be this one. Call it test.txt. Now, this file will be holding your input that will be parsed using the grammar that you are going to define. Now, the input in this test.txt file will be something like this. So I have put several values, alphanumeric values, which are comma separated and within brackets. As you can see, the input doesn't have any spaces and it's a bit stressful for the eyes. So the goal of this project is to actually print this, is to actually parse this input and print it out in a pretty format. Now, that being said, this is the main function which has the code that will parse the input which we just saw, and it will provide the output as follows. So as you can see, the output should be something like this, which is, you can see now it has more spaces, and I can see that, okay, which value is which, because it now looks a bit more pretty to the eyes. So this is an example of pretty print. But though this is the output, let's look in detail how we can achieve this. Now, going back to the grammar file, which is the csv.g4, let's go through some of the terminologies. Now, if you can recall, in the lectures, I have already mentioned that the grammar file holds a set of rules that define that how the grammar for the particular language should be, so that given the input can follow the rules of the language. So in the grammar file, when you see each of these, let's say, lines that are written, or these rules, these are actually called production rules, or simply production. Now, production rule technically consists of non-terminals, which is like, here is the list. So non-terminal is something which consists of, let's say on the right-hand side, it consists of symbols that can be extended further to terminals. And by terminals, I mean beg L, end L. These are terminal symbols because these cannot be further expanded. Usually the convention is that in the Antlr grammar file, non-terminals are denoted with small letter like alphanumeric value. So whatever happens, you can see the terminals actually begin with, or they usually are written in capital format, but the non-terminals are written in small letter format. Another thing you must already be aware that in grammar file, precedence is very important. So whatever you put on the top is given higher precedence than the one in the bottom to that. Now, the first production rule is thought as the root production rule. Now, during the lecture, we have also learned the theory behind regular expression. Now, this is a regular grammar. So if you substitute every non-terminal, so like, I mean this one. So these are the non-terminals, right? Like list, LMs, LM. So the non-terminal of the production rule. So if you substitute every non-terminal with its right-hand side, you can reduce it down to a single production rule for the root with only tokens and operator on the right hand side, this reduced form of a regular grammar is regular expression. Now, what does it mean in practice? So based on these production rule like list, LMs, LM, I have written them down in a notepad. Now, these are the production rules that define the CSV parser grammar. So if what we mentioned that you have the list, which is a root production rule or the root non-terminal. Here on the right hand side, if we substitute it with terminals such as like operators and tokens, then we will come to the regular expression for the production rule, root production rule of the grammar. So let me put this into practice. What I'm going to do, I'm going to delete this bit and I'm going to exactly show you how to derive the regular expression for the root production rule of this grammar, right? So if you can remember the non-terminals, the root non-terminal is a list which says you have begin, then LMs question mark, which means whether there is LM or not. So it checks for whether LM says empty or it has a value. So begin, LMs, and then end. Begin is technically the bracket as it's mentioned here based on the rule. And ender is the closing bracket or the right hand bracket, right? So if the production rule is this one, I have copied it here as well. Let's now expand that, expand this rule. So as you know, we can replace LMs with the production rule for the LMs. So let's copy it. Let's copy the production rule apart from the semicolon. So if I replace LMs, this we have already now expanded the production rule based on the like production rule of LMs. Now you can see here we have separator and here we also have LM. So separator and then LM. Let's replace the production rule using the production rule of separator and LM. So separator is technically comma. So let's okay, let me copy this first. I'm so sorry. Yes, so here we can replace separator with this, and we can also replace LM with this production rule. Perfect. Now it's already, you can see that when we are substituting, we are actually replacing the rules for the root non-terminal production rule, which is the list for this grammar. Excuse me. So let's copy it in the next line again so that we can replace. So here, okay, another thing you can see that I forgot to replace the LM here as well. So let me replace that. Yes, now it's correct. So if we have this, now we have to replace each of these. So let me just copy this onto the previous. Okay, perfect. Now, let's expand this rule based on the terminal values. So ID or num. So ID's rule is this, and the num's rule is this. Now let's do the same for this side and for ID as well. Perfect. So you can see now we have replaced the middle bit with all the terminal rules that we have here. And we are yet left with one more thing. Now we have to replace the big L and end L. So that would be, if we replace that, and we are going to actually copy everything in the middle, and end L will be replaced by the terminal rule perfect. So this, as you can see, is actually, so list, which is the root non-terminal or the root production rule. This one can technically be defined by the rule consisting of set of terminals, which is like this. Now this whole like this form is actually the regular expression for this grammar. Now that we have understood that what is the, like how regular expression plays a part in the practical sense of grammar, another reason I would also like to touch base is that the reason I showed this expansion is because, let's say you want to make your grammar do more complicated things, more complicated than just like reading CSV file. So if you want your grammar to be able to parse codes, like building a compiler and building the grammar for your own language that you are going to define. So it's very important to understand regular expression, because if you do not understand how it works out for your grammar, then you might not be able to define your grammar correctly. And that's why I wanted to show you with an example that how this regular expression plays an important part in defining or designing your own grammar. Now that we have seen this part, let's go back to your IDE. In the IDE, so you should have already created the CSV.g4 grammar file with the code. I have made slight modification from, as I've already mentioned, the modification is that this grammar is able to handle not just number, but at the same time, like digits as well. Digits in the sense like alphabets as well. So it is capable of handling alphanumeric, which you can see in the input. So in the text file, test.txt file, the input, you can see it's they consist of 3 alphanumeric values. So I've modified this grammar to be able to parse that. Now, after you have already created the csv.g4 file, it's time to auto-generate the listener and visitor and parser by using the Antlr tool. But before you do auto-generate, make sure, click on the csv.g4 file, right click on it, and make sure to click on the configure Antlr. You can also do the same from tools. So in the menu, if you click on tools, you should also find configure Antlr option. If you click on it, make sure that the output directory is the path to your source folder for your project, or else you might not be able to get the exact same result as I am getting here. Now, once you have done that, right click, click on the csv.g4 grammar file, right click on that grammar file, and then do auto generate Antlr recognizer. When you click on this one, you will see Antlr will automatically generate several files for it. Will generate tokens, listener, visitor, the parser that we have already mentioned in previous labs and lecture as well. But now let's look in detail how you can build a pretty print visitor which will go through each node created, like each node of the parse tree generated by Antlr. So whenever the input is provided, Antlr creates token from it. The token, from the token, then like parsing happens, or the parser processes the token and creates the parse tree. Now, using visitor class, you can visit each node of the parse tree to do some further processing. Now, before we create that visitor class, which is able to output this pretty print of the input, let's look at the CSV base visitor that is auto-generated by your Antlr. Inside, you will see that automatically Antlr has created here functions or method depending on the production rule of your grammar. So in the grammar file, you can notice that you have like production rule list, LMs, and LM. So these production rules, based on the same names, you will see Antlr has generated methods called visit list, visit LMs, and visit LM, because these are the node in your parse tree generated by the parser of the Antlr for the input provided. So our job, if we want to get the pretty print output like this, as shown, our job is to extend this CSV base visitor and write the function to do that. The way we do that, now click on the source folder again, right click on it, create a new Java class and call it prettyvisitor.java. Now you can say I already have the code for that in front of me, but the way you create this pretty visitor is that you extend the CSV base visitor class, because in the CSV base visitor, Antlr automatically generates the template for method visit list, visit LMs, and visit LM, which are, you can remember, they are the non-terminals or the production rule for your grammar. So you have to extend these methods inside your pretty visitor.java class. And that is how you can use your visitor to like do further processing on the nodes of the parse tree. So let's look at each of them, each of the method, how we extend. So here we are redefining the visit list method in the pretty visitor, where what we are doing, we are actually going through each of the node, and here we are putting extra spaces. So whenever it finds an element from the node, then we put extra spaces to make it look a bit more like manageable. Now you can see another thing. So if you can see, there's a, in the output here, you have spaces here. So spaces before the value and ends the space end of the value. You can see actually this string is following the same format as well. So the space here and the space there. And here we are actually processing the visit LMs. So the each of the LMs value will be processed here. Now, the visit LMs is again another method that we are extending. What we are doing, that we are going through each of the elements, and then we are just printing it out based on a comma, and we are putting an extra space here, which is shown in this line. And finally, we are also extending the visit LM method, where we are just returning whatever text we are getting. We are printing that out, or actually we are like returning that as the value for the method. So this is how we created a visitor class, expanding the base visitor so that we can generate the output like this based on the input that we have provided. So after like you have expanded the visitor, one more thing, again, the main function is nothing very different. It's the same main function where we create the lexer. First we create a character string where we read the input from the text file. Then we create the lexer, which will generate the tokens. So we create the lexer object, and the lexer then generates the token. And the token then is processed by the parser. So we create the parser object, and we pass the tokens to the parser. And after that, here, what we are doing, we are explicitly calling the visitor object, and we are passing the parse tree to that, so that the visitor can visit each node of the parse tree and print out the pretty print for the input. So I hope this shed a bit more in-depth light on how to work with visitors and what is the correlation between regular expression and regular grammar, especially in practical sense. So thank you again for attending, and I will see you in lab or in class.